Today we are going to talk about the gravity and acceleration due to gravity, how they are related and how they are different. Let's start. First, I want to tell you about the gravity. This is, let's say, a heavenly body, and if another body is lying on its surface or near to its surface, which is comparatively very small, then the gravitational force between them is called gravity, or we can say that this is the force of attraction of heavenly body acting on that body is gravity. The attraction is towards the center, and it can be defined this way: the force of attraction of heavenly body acting on the another body lying on or near its surface towards the center is called gravity of that heavenly body. Now let's go forward. Gravity is also called gravitation. What it mean exactly? Gravity and gravitation are basically the same. It means, let's take one example. These are two bodies. They attract each other according to the concept of gravitation. If a body has mass, then it attracts another mass. And this attraction force between any two bodies of this universe, it may be sun and earth, or maybe moon and earth, or maybe dust particle also. One dust particle attracts another dust particle, and maybe very small, very big. If a body has mass, it has the power of attraction, and this attraction is named as gravitation. But if one of them is very huge in comparison with another, and another which is very small lying on or near its surface, then the force of attraction between these two heavenly bodies is called gravity. That's why we can say that the force of attraction between any two bodies of the universe is called gravitation. But among those two bodies, if one is very huge and another is comparatively very small and lying on or near the surface of the bigger one, then the gravitation between them is termed as gravity. So gravity is also actually gravitation. This way we can answer nicely. Okay, let's go forward. Then what are the basic difference between gravity and gravitation? One becomes definition. The force of attraction of the heavenly body acting on another body lying on or near its surface towards its center is called gravity of that heavenly body. In place of a heavenly body, we can say earth also. The force of attraction of the earth acting on the body lying on or near its surface towards its center is called gravity of the earth. We can define this way also. Gravitation, the mutual force of attraction between any two bodies of the universe is called gravitation. Okay, next difference is it is also gravitation, but a special condition of gravitation. And gravitation, it is true for all the bodies of the universe, whether the body is very big or very tiny, very small. This way actually gravity comes under gravitation. Both of them are force and both of them have the same unit, Newton. Okay, let's go forward. Now I want to talk about acceleration due to gravity. This is a very important term. What is exactly acceleration due to gravity? First, I want to tell you about the acceleration, and then we'll be able to understand acceleration due to gravity. I want to explain a little about the acceleration. If a body is moving in this straight path, at first its velocity is 0. It means it starts from rest. At the end of 1 second, its velocity is 2 meters per second. At the end of 2 seconds, velocity is, let's say, 4 meters per second. In the same way, 6 meters per second and 8 meters per second. Looking at this value, we can say that the body is moving faster and faster. Its velocity is increasing and increasing, and that's why this is accelerating. Just opposite of this, if a body moves in another fashion like this, 8 meters per second is initial velocity. After 1 second, 6 meters per second. Another 1 second, 4 meters per second. This way, every second, if velocity of a body goes on decreasing, then the body is said to be moving with acceleration. It means if the velocity of a body keeps on changing, then the body is said to be moving with acceleration, whether the change is positive or negative, whether the velocity is increasing or decreasing. But if a body is moving in such a way that every second velocity increases or decreases, then the body is said to be moving with acceleration. Okay, now rate of change of velocity is called acceleration. We can define acceleration like this, and it is denoted by the symbol a, and its SI unit is meter per second square. Okay, now let's talk about acceleration due to gravity. When a body is dropped from certain height, then it comes down in a straight line path and its direction is towards the center of the earth. When it was at the height and not dropped, at this time its velocity is 0 meter per second, and after 1 second its velocity will increase to 9.8 meter per second, and at the end of another 1 second its velocity is more than that, 19.6 meter per second at the end of 2 seconds, and at the end of 3 seconds its velocity is found to be increased and it is 29.4 meter per second. In this way, every second its velocity is increasing and increasing, and the body has acceleration, we can say, very easily. And in first second its velocity was less, that's why distance covered is less. In second velocity increased, that's why distance covered is more than that. In this way, every second increment of velocity is 9.8 meter per second. From 0 to 9.8 meter per second, it is 9.8 meter per second is the increment, and 9.8 to 19.6, again the increment is 9.8. Actually, acceleration is denoted by a, but this acceleration is produced due to the force of attraction of the earth, that is gravity of the earth. Since this acceleration is due to the gravity of the earth, so it is named as acceleration due to gravity, and it is denoted by small g. You have to remember that a represents acceleration, g represents acceleration, but a represents acceleration produced on a body due to the applied force, or produced on a body due to the force applied by engine or force applied by a man or something. But the acceleration produced on the body due to the pulling force of the earth is named as acceleration due to gravity, and it is denoted by small g. Let's go forward. How can we define now acceleration due to gravity? Acceleration developed on a freely falling body due to the gravity of the earth is called acceleration due to gravity. Freely falling body means acceleration due to gravity can be expected in vacuum only, because free fall is possible only in vacuum, but in the open place there is air. That's why acceleration produced in air is exactly not the acceleration due to gravity, because air resists the motion of the body. Its average value is taken as 9.8 meter per second square. This means a body is if dropped at different place of the earth, what is found, in average it falls with acceleration of 9.8 meter per second square. Its value changes a little in different places, but at 45-degree latitude its value is 9.8 meter per second square. That's why this is taken as standard. Let's talk a little more about the falling body. What was expected at the beginning? Aristotle told that a heavy body falls faster than a light body. No one checked his idea but accepted. His thinking was accepted at that time, but later Galileo tried to check it. This was old idea, means when a heavy and a light body is dropped from the top of the tower, heavy falls faster and the lighter one falls later. It means acceleration due to gravity is more in case of heavy body, in case of more mass, and it is less in case of less mass. But later Galileo dropped two cannonballs from the top of the leaning tower of Pisa, and what was found at that time, in every experiment both of them fell simultaneously. That's why the old idea is rejected, a new idea is adopted. And what is the new idea? Acceleration due to gravity is same for every object irrespective of its mass. Okay, Galileo's experiment of leaning tower of Pisa, if you are told what was the experiment, you can say this way. Experiment was Galileo dropped two cannonballs of different mass from the top of the leaning tower of Pisa. Both of them fell together on the ground. This was the experiment. And if you are told to write conclusion, then you can say that conclusion, it proves that acceleration due to gravity for every substance is same irrespective of their mass. At that time, question was raised by the people, if it is so, then why a feather doesn't fall together with a stone? At that time, Galileo replied that if I get a place where there is no air, then I can drop both of them together, because this is due to the air resistance. Air resistance opposes the motion of the feather and it falls later in the air, but in vacuum both of them falls together. When a stone and feather is dropped in air, then exactly what happens to the stone and feather, due to which feather comes later, stone comes first? The reason is very simple. Stone falls faster than that of the feather. It is due to the air resistance. Mass of feather is comparatively very less than the stone. So, gravity of earth acting on the feather is negligible, which can be easily neutralized by the air resistance. Thus, due to the lack of gravity force, feather falls with uniform velocity. On the other hand, gravity on the stone cannot be neutralized by the air. So, it accelerates and falls faster. There is a famous experiment related to feather and coin. It was first done by Newton, and he took 1 meter long glass tube and he kept the coin and the feather inside the tube, and he quickly inverted the tube. What is found? Coin fell first and then feather came later. And this is explained in this way. There is air resistance opposes the motion of the feather, and that's why it fell later. By using vacuum pump, air is pulled out, and again when the tube is quickly inverted, then what is found? Both of them held together in vacuum because air is now not present in the tube. This way, this experiment says that both of them falls together in vacuum because there is no air resistance, and acceleration due to gravity for every substance is same irrespective of their mass. It can be understood by this video clip also. Look at this video clip. A ball, heavy ball, metallic ball and a feather is falling together in the vacuum. When they are dropped from certain height, then because of the vacuum, both of them have same motion. Their acceleration is same. Acceleration due to gravity is same for every substance, whether its mass is more or less, and they falls together simultaneously. Look at this. There is another famous question. A paratrooper lands safely on the ground. How it is possible? We can answer this way. Just say this is a paratrooper and the area of the parachute is very huge, and air resistance increases with the increase of surface area. If he jumps from aeroplane, then landing is safe. The reason is very simple. The force with which he is falling is the gravity of the earth acting on his body and parachute. Let's say it is 1000 Newton. Just to understand the matter clearly, I am taking the value. It's not necessary to be 1000 Newton, but the air resistance which acts against the gravity is if equal to the same value. I mean to say, air resistance becomes very huge and it can neutralize 1000 Newton force. I mean to say, air resistance is if 1000 Newton, then force of gravity is neutralized. It means without the force, of velocity of the body cannot increase, so he falls with uniform velocity. If a man falls with uniform velocity, then landing will be safe. This way we can write surface area of parachute is very high. That increases the air resistance which neutralizes the gravity of the earth acting on the paratrooper. So he falls with the uniform velocity due to the lack of gravity. So his landing is safe. After all this explanation, I want to present some of the question. Which one of the following options represents the symbol of gravitation, gravity, acceleration due to gravity and gravitational constant respectively? The options are number 1, F, G, small g and capital F again. And capital G, capital F, small g and capital F. Number 3, G, capital G, F and F. And F, F, G and G. Looking at this, there are F and G only. Now we have to go through question. following options represents the symbol of gravitation first, and then gravity, and then acceleration due to gravity, and then gravitational constant. What is symbol for gravity? This is a force F. That's why F, again F, and acceleration due to gravity is denoted by small g, capital F, small g, and lastly gravitational constant is capital G. So capital F, small g, and capital G, we have to source it. Capital F, another is not capital F, both are not capital F, first two are not capital F. This one is the correct answer, capital F, small g, and capital G. In the same way, look at this another question. Which one of the following options represents the unit of gravitation, gravity, acceleration due to gravity, and gravitational constant respectively? First one is Newton, Newton meter square by kg square, meter per second square, and Newton. And second one, Newton meter square by kg square, Newton meter per second square, and Newton. The same is here and same is here, but here and there they are scattered. Okay, we have to go through question. Gravitation is force, so its unit is Newton. These three have Newton, that's why 4 is cancelled. And second, gravity here is not Newton. Gravity is also force measured in Newton. This third only exists. First and second we can cancel because second is not Newton. Here Newton meter square by kg square, here not Newton. And that's why third exists. Gravitation Newton, gravity Newton, and acceleration due to gravity is measured in meter per second square, and gravitational constant is measured in Newton meter square by kg square. It means third option is correct. That's why we'll select this third option. This is the practice of the units related to this chapter and the symbol related to this chapter. Okay, now I want to stop. We'll meet in another class.